This video is going to walk you through the basic derivative rules, and I'm going to talk through what my list is here. So starting with a function that is just a number, a constant, k. The derivative of a constant is 0. Pretty straightforward. Second rule, we have just a plain old x. The exponent for this x is 1. We don't write it. The coefficient, little m, is just some number. And when we take its derivative, it's just the coefficient. And the big takeaway for that is that anytime you have a coefficient, it's always going to be a part of the derivative. That coefficient does not go away. Third rule, x to a power other than 0 or 1 works, but we typically don't separate it. Anyway, so x to some power, that exponent little n becomes a coefficient. It goes in front of the x, or whatever the variable is, and then the new exponent for the derivative, you subtract 1. And that n, like I said, it could be a negative, it could be a fraction, it's not going to be 0. The fourth rule is for an exponential function, e to the power of just x. Nothing changes. The derivative is e to the power of x. Fifth rule, natural log. There are other logarithms, but we don't deal with them. The derivative of the natural log is 1 divided by x. Notice the derivative does not have a logarithm as part of it. Rule 6, we get kind of combo here. It's similar to rule 2, but the g of x is normally a more complicated function. So k for the coefficient, it's always there, and then whatever that function is, you take its derivative according to the rule. And that could be any of the previous 5. The second number 5, which would be number 7, is when we add or subtract things together. You just treat them as separate things and take their derivatives one at a time. Alrighty, let's take a look at a couple of examples. So our first one is q of p is equal to negative 3 times p squared minus 2p. And take a look at the answer here. So q of p, and then our derivative. So the negative 3 is a coefficient. It's a part of the derivative. The 2 is the exponent of the first p, so it goes in front with the negative 3, and then the exponent becomes 2 minus 1. And the second term, so we're using rule 5 here in conjunction with the other rules. So the second term, minus 2p, it's going to be rule 2. We just have a coefficient and a plain old variable, no extra exponent. So it's just the coefficient, minus 2. And then do a little bit of cleanup. Negative 3 times 2 is negative 6, and 2 minus 1 is 1. We don't write the 1 exponents. The second one, capital S of w, negative 3 divided by w squared. Some of the times it's a good idea to know, do I use a special rule or do I simplify it with algebra and use one of the basic rules? So the next video we talk about using a rule for dividing things, which is really overkill for this situation. So I use the algebra rule that says when we have a variable in the denominator, we can put it kind of on the top level and change the sign of the variable. So you do need to know all of those exponent laws for this class. So now we've got negative 3 times w to a power. That's rule, combination rule 3 and 2, or rule 6. So its derivative, the coefficient, is negative 3. It stays there. The exponent is negative 2, so it goes in front. And then the new exponent is negative 2 minus 1. So simplify that a little bit. The two negatives cancel. 3 times 2 is 6. The exponent, negative 3. And my little note on the side here, I have seen a lot of students that want to do everything all at once. And most of the time, they make mistakes. So I highly recommend that you go slow and you break it apart into little pieces and you do things separately. Alrighty, the third one here, capital T of u, we've got pi times the natural log of u minus 2 over the cube root of u squared. Lots going on here. So again, this first line, I have taken it and simplified it with a couple of exponent laws. The radical becomes this exponent, the cube root of u squared is u to the 2/3 power. That's in the denominator. So just like the example B, we move it up to kind of the top level. Okay, so take the derivative. Pi is a coefficient, so it's part of the answer. Natural log, a special rule, the derivative is 1 over x. Then minus the 2 is the coefficient, it stays there. The exponent is negative 2/3, it comes down in front, a new part of the coefficient. And then the exponent, negative 2/3 minus 1. That's always the rule for the power rule, is the original exponent minus 1 is the derivative exponent. So simplify it a little bit, pi over x plus, the two negatives cancel, so you get plus 4/3 u to the negative fifth thirds. And then the final example, another polynomial. So we've got 3 terms here. So we'll take the derivative p squared. That's the power rule. 2 comes in front. The exponent 2 minus 1. That's something I did in my head. And then we've got minus 2 times e to the p. So the minus 2 is the coefficient. It's there. The derivative of e to a power is e to the power. We'll learn special rules when it's a more complicated exponent. And the plus 3 is a constant. There's no variable with it. The derivative of a constant is 0.